How does the sun burn without oxygen in space? Have you ever pondered how the sun can shine so brilliantly in the vast emptiness of space, where oxygen, the traditional fuel for fire, is absent? This intriguing question has captivated the minds of many, and thanks to advancements in science, we now have a clearer understanding of this cosmic phenomenon. The sun, contrary to popular belief, is not burning in the conventional sense. Instead, it is powered by a remarkable process known as nuclear fusion. At the heart of the sun lies its core, where temperatures soar to an astonishing 27 million degrees Fahrenheit, about 15 million degrees Celsius. In this extreme environment, hydrogen atoms are subjected to immense pressure, causing them to collide and fuse into helium. This fusion process releases an incredible amount of energy, which radiates outward from the core, eventually reaching Earth as the sunlight and warmth that sustain life. The sun's core operates like a cosmic pressure cooker, with gravity providing the necessary force to overcome the natural repulsion between hydrogen atoms. Under these extreme conditions, four hydrogen nuclei combine to form one helium nucleus, with a small fraction of mass converted into energy, as described by Einstein's famous equation, E=mc². This energy is what powers the sun and allows it to shine for billions of years. The sun's layers, a journey of energy. The energy generated by nuclear fusion in the sun's core takes a long and complex journey outward through its various layers. The first layer, known as the radiative zone, is where energy travels in the form of photons. These photons bounce around in the dense solar plasma, a process that can take over 100,000 years before they reach the next layer, the convective zone. In the convective zone, hot plasma rises to the surface, cools, and then sinks back down in massive looping currents, akin to a pot of boiling water. These convection currents create the sun's granular appearance, with each granule roughly the size of Texas. The visible surface of the sun, known as the photosphere, is just the beginning of its expansive atmosphere. Above the photosphere lies the chromosphere, a thin, reddish layer that can only be observed during a total solar eclipse. Here, temperatures rise sharply from about 10,000 degrees Fahrenheit 5,500 degrees Celsius to nearly 1.8 million degree F, 1 million degree C. The outermost layer of the sun's atmosphere is the corona, a wispy halo of plasma that extends millions of miles into space. Surprisingly, the corona is much hotter than the surface, reaching temperatures of up to 3.5 million degree F, 2 million degree C. Scientists are still investigating the mechanisms that heat the corona to such extreme temperatures, with theories suggesting that magnetic waves and nanoflares may play a significant role. The sun's influence on Earth and beyond. The sun's influence extends far beyond its visible surface. The solar wind, a continuous stream of charged particles, flows outward from the corona at speeds exceeding 1,000,000 miles per hour, 1.6 million kilometers per hour. When these particles interact with Earth's magnetic field, they can create stunning auroras and disrupt satellite communications. Fortunately, Earth's magnetic field acts as a protective shield, deflecting most of the solar wind and preventing it from stripping away our atmosphere. Without this invisible barrier, Earth could have faced a fate similar to Mars, which lost its atmosphere and water due to relentless solar bombardment. The future of the sun, a cosmic timeline. The sun has been shining for approximately 4.6 billion years and is expected to continue its luminous journey for another 5 billion years. However, it will not remain unchanged. As the sun consumes its hydrogen fuel, the core will contract and heat up, causing the outer layers to expand. In about 1.1 billion years, the sun will be about 10% brighter than it is today, potentially making Earth too hot for life as we know it. Eventually, the sun will exhaust its hydrogen supply and begin fusing helium into heavier elements like carbon and oxygen. At this stage, it will expand into a red giant, engulfing Mercury and Venus, and possibly even Earth. But that's a story for the distant future. For now, we can marvel at the sun's power and appreciate the delicate balance that allows life to thrive on our planet. Thank you for watching the video. For more content, don't forget to like, share, comment, and hit the subscribe button and bell icon.